Evaluate the integral from 0 to 1 of the quantity 3t minus 1 raised to the 50th power dt. Now, this is a situation where the substitution rule is going to be very, very useful, because if we didn't have it, we would have to expand 3t minus 1 to the 50th power as a polynomial, which would be absolutely insane. But instead, we can make a simple substitution. Let's let u be 3t minus 1. That means that du is 3 dt. And we don't have 3 dt, so we're going to divide both sides by 3. So dt is going to be 1/3 du. And we can start making our substitution. We've got the integral of, the inside becomes u to the 50th du. That dt is going to be replaced by 1/3 du, so we need that 1/3 out front. And we're going to have to come up with new limits of integration. So our upper limit was t equals 1. When t equals 1, u is going to be 3 times 1 minus 1, which ends up being 2. And for our lower limit, t equals 0, u is going to be 3 times 0 minus 1, which is -1. So our limits become 2 and -1. And once we've converted everything over to u, we can just integrate. We've got the 1/3 out front, and the antiderivative of u to the 50th is going to be u to the 51st over 51. And that's going to be evaluated at -1 and 2. And so we've got 1/3 times 2 to the 51st over 51 minus -1 to the 51st over 51. Now, -1 to the 51st is still going to be -1, but when we're subtracting a negative, it turns into adding. So this is going to be 1/3 times 2 to the 51st plus 1 all over 51. And we can distribute that 3 in. Not distribute, sorry. We can just multiply that 3 into the bottom. So this is going to be 2 to the 51st plus 1 all over 153. And I'm not even going to try and calculate 2 to the 51st power, because 2 to the 10th is 1024. And so if we're raising this to the 51st power, it's going to be something in the well past trillions. In a situation like this, we can just leave it as 2 to the 51st plus 1 over 153. There's no sense in trying to get this in scientific notation or anything like that. We can just leave it like this.